In question 1, we've got the point P with coordinates -4, -3, and we need to determine where this will be mapped under the transformation of y is f of 2x. Well, we know that the 2x means that we divide x by 2, and therefore the point -4, -3 will be mapped to -2, -3. In part B, we're dealing with y is 3 f of x minus 1. Well, the x minus 1 means we are adding 1 to x, whereas the 3 outside means all the y's get multiplied by 3, and therefore -4, -3 will be mapped to -3, -9. In part C, we've got y is the modulus of f of x, where the modulus sign here is making all the y values positive. It's reflecting along the x-axis so that the graph appears in the positive y's. So this means that the -4, -3 will now be found at -4, 3. In 2a, we've got the curve here defined to be x to the power of 4 minus 5x squared plus 4x minus 7, and we need to show that there is a root to f of x is 0 in the interval 2 to 3. So this is a classic question where we're looking for a change of sign. So I will be evaluating f of 2, which is going to be 2 to the power of 4 minus 5 times 2 squared plus 4 times 2 minus 7. This gives an answer of -3, which is less than 0. Whereas f of 3, I will substitute x with 3, so 3 to the power of 4 minus 5 times 3 squared plus 4 times 3 minus 7, which gives an answer of 41, which is greater than 0. And therefore we conclude that there is a change of sign and f of x is continuous, so a root exists in the interval 2 to 3. We need to mention both the change of sign and the continuity of f of x to get the second mark. In part B, we need to show that the equation f of x is 0 can be written in this form. So starting with f of x here, I will start by writing x to the power of 4 minus 5x squared plus 4x minus 7 is equal to 0. The first thing to do is isolate the x to the power of 4. So we've got x to the power of 4 is 5x squared minus 4x plus 7. And I will divide throughout by x to get x cubed is 5x squared minus 4x plus 7, and all divided by x, which means that x should be the third root of 5x squared minus 4x plus 7 over x as required. In part C, I need to use the given iterative formula starting with x1 is 2 to find the value of x2 and alpha to 4 decimal places. So for the first part, I will be substituting x1 is 2 to find x2. So wherever we've got xn, I'll be putting the number 2. This means that x2, it's going to be 5 times 2 squared minus 4 times 2 plus 7, and all divided by 2. And I will take the third root of this. So if I go on my calculator, I press 2 and the equal sign, and I take the third root, and I will write the expression there, 5 uns squared minus 4 uns plus 7, and everything divided by uns. So each time I press the equal sign, we get a new iteration. I press it once, I get the value of 2.1179. And for the value of alpha, I will keep pressing. I see that the decimal places start to stabilize. So after a few presses of the equal sign, I see that we are tending towards 2.1565, which is the value of alpha correct to 4 decimal places. In question 3, we are modeling the amount of money raised for a charity. So the amount of money is capital D, the time is t months. We are given this equation here, and we need to write this equation in the form D is AB to the T, with A and B being constants to be given to 4 significant figures. So starting with what we are given, I will take log base 10 of both sides. So log D base 10 is equal to log of AB to the power of T base 10. This means that log of D base 10 is log of A base 10 plus log of b to the power of t base 10, which can be further simplified into log of d base 10 is equal to log of a base 10 plus t log of b base 10. This means I can easily compare it with the equation I was given. So the log of a base 10 is the constant of 1.04, whereas the log of b base 10 is the coefficient of t here. So we conclude that log of a base 10 is equal to 1.04 and log of b base 10 is equal to 0.38, and therefore a is 10 to the 1.04, b is 10 to the 0.38. If I plug this on the calculator, I find that a is 10.96 and b is 2.399, and therefore the equation of the model is d is 10.96 times 2.399 to the power of t. In part B, we are told that when t is capital T, the total amount of money raised is 45,000, and we need to determine the value of capital T to three significant figures. So we were given that log of d base 10 is 1.04 plus 0.38t, which means that now that d is 45,000, we are looking at the log of 45,000 base 10 is 1.04 plus 0.38 capital T, and I need to solve for capital T. So we've got log of 45,000 base 10 minus the 1.04 is 0.38 capital T, and of course log of 45,000 base 10 minus 1.04, and everything divided by 0.38 should be giving me the value of capital T, which gives an answer of 9.51. And finally, in part C, we are told that we are aiming for 350,000 over the first 12 months of monitoring, and we need to assess whether the charity will achieve this aim. Well, we've got the equation of the model, so what I will do is I will evaluate capital D when t is 12, so 12 months after the monitoring began. So D is going to be 10.96 times 2.399 to the power of 12. This gives an answer of 398,107, which is greater than 350,000. And therefore we conclude that according to the model, the charity will achieve its aim. Notice that here anything which runs to 400,000 is acceptable to claim the marks. In question 4, we're given the function f of x here, and we need to show that it simplifies to 2x over 3x minus 5. So I will start by factorizing the numerator and the denominator of the first fraction here. So I will take out a common factor of 2, leaving me with 2 brackets x squared minus 16. The denominator factorizes into 3x minus 5 times x plus 4, and the second fraction stays as it is. It's 8 over 3x minus 5. We should be able to recognize x squared minus 16 as the difference of two squares, so x minus 4, x plus 4 over 3x minus 5 times x plus 4, and I've got the plus 8 over 3x minus 5. Well, the x plus 4 with the x plus 4 will cancel out. I see the common denominator of 3x minus 5, which means I've got 2x minus 8 plus 8 over the 3x minus 5, which simplifies to 2x over the 3x minus 5 as required. In part B, we need to use calculus to show that f is a decreasing function. So calculus here means differentiation. So let me start by finding an expression for f dash of x. I will be applying the quotient rule of differentiation. So I differentiate the top, which leaves me with a 2, and I keep the bottom of 3x minus 5, minus I keep the top and I differentiate the bottom. The derivative of the bottom is 3, and all of it over the bottom square, which is 3x minus 5 all squared. This simplifies to 6x minus 10 minus 6x, and all of it over 3x minus 5 squared. So the 6x with the minus 6x will cancel out. So all in all, f dash of x is minus 10 over 3x minus 5 squared. Now, to show that f is a decreasing function, we need to bear in mind that if f is a decreasing function, then its derivative is negative. So what we need to say is that 3x minus 5 all squared will always be greater than 0, and therefore minus 10 over 3x minus 5 all square will always be negative. So essentially what we are saying is that f dash of x will always be less than 0, and therefore by definition f is a decreasing function. In part C, we've got g of x to be 3 plus 2 ln x, and we need to find g inverse. So we start with y is 3 plus 2 ln x, and the first thing to do is interchange x and y. So x is 3 plus 2 ln of y, and we're trying to make y the subject. So x minus 3 is 2 ln y, which means that x minus 3 over 2 is ln y. I will remove the ln by saying e to the x minus 3 over 2 is equal to y, and therefore g inverse of x is e to the x minus 3 over 2. I also need to provide the domain of this, and to do that I need to consider the range of g of x, because we know that the range of g is the domain of the inverse. So for g of x, we start from x is greater than or equal to 1, which means that ln x is greater than or equal to ln of 1, which is 0. So 2 ln x is greater than or equal to 0, and therefore 3 plus 2 ln x is greater than or equal to 3, which means that y or g of x is greater than or equal to 3. This is the range of g, which is the domain of g inverse, and therefore I need to state that x is in the reals and x is greater than or equal to 3. So what we did here is that we reconstructed the expression for g of x in order to derive its range, and from the range of g of x I can safely conclude the domain of the inverse. In part D, we need to find the exact value of a for which g of f of a is 5. So on the left hand side we've got the composite function g of f of a. I will start by doing g inverse on either side. So g inverse of g of f of a is g inverse of 5. This means that on the left hand side g inverse with g will cancel out, and we're looking at f of a is e to the 5 minus 3 over 2. So we're looking at f of a is equal to e. Now we know that f of a is going to be 2a over 3a minus 5, which is equal to e. I will cross multiply to get 2a is 3ae minus 5e. Remember, we're trying to determine the exact value of a, so this means that we've got 5e is 3ae minus 2a. I will factor out the a on the right hand side, leading to a brackets 3e minus 2, and therefore we arrive at 5e over 3e minus 2 to be the value for a. In question 5, we've got the temperature capital T degrees Celsius of the air in a room T minutes after a heat source is switched off. Being modeled through this equation here, a and b are constants. We are told that the temperature at the instant when the heat source was switched off was 18 degrees Celsius, and we need to find the value of a. So in other words, we have just been told that when small t is equal to 0, then the temperature capital T is 18, which means we're looking at 18 being equal to 10 plus a e to the 0. So we've got 18 is equal to 10 plus a, and therefore a is equal to 8. Given also that 45 minutes after the heat source was switched off, the temperature was 16 degrees Celsius, we need to determine the value of b to 3 significant figures. So we know that when small t is 45, then capital T is 16, and therefore 16 is equal to 10 plus 8, which is the value of a we just obtained, e to the minus 45b. So 6 is equal to 8 e to the minus 45b. I will divide both sides by 8 to get 6 over 8 is equal to e to the minus 45b. I will take ln of both sides, so ln of 6 over 8 is equal to minus 45b. And if I divide both sides by negative 45, we get minus 1 over 45 ln of 6 over 8 to be equal to b. If I plug this on the calculator, I get 0.00639 for the value of b. In part C, we need to use the values for a and b to find the rate of change of the temperature exactly 2 minutes after switching off the heat source. So we know from the previous part that capital T is 10 plus 8 e to the minus bt, and we've got the value of capital B. So the derivative, the capital T, the small t, will simply be 8 times minus b e to the minus bt. So I will be evaluating this when small t is 2, so 2 minutes after switching off the heat source. So when small t is 2, we've got minus 8b e to the minus 2b. We've got the value of b to be 0.00639, so this is minus 8 times 0.00639 times e to the minus 2 times 0.00639. I plug this on the calculator and get an answer of minus 0.0505, and this is degrees Celsius per minute. In part D, we need to explain why, according to the model, the temperature cannot fall to 5 degrees Celsius. Well, the equation of the model is here. It's capital T being equal to 10 plus 8 e to the minus bt. And we know that as t goes to infinity, then e to the minus bt goes to 0. So the exponential term vanishes, and therefore t goes to 10. This is actually the minimum temperature that we can attain. And since we've got capital T being greater than 10 for all values of t, we can never fall to 5 degrees Celsius. In question 6, we've got a sketch of the curve with equation f of x is 2e to the 3 sine x cos x, and we are told that we are intersecting the x-axis at point R shown here, and we need to state the coordinates of R. Well, let's first notice that R is the second cut on the x-axis. There is another cut here. We know that if we are cutting the x-axis, this means that y is 0. So at R, y is 0. So I will be setting 2e to the 3 sine x times cos x is equal to 0. Now, obviously, e to the 3 sine x can never be 0. So the solutions to this will come out of cos x being equal to 0. Now, my PV will be shift cos of 0, which is pi over 2. And therefore, x is plus minus the PV of pi over 2 plus 2 pi k. This gives me the first two positive solutions to be pi over 2 and 3 pi over 2. And therefore, the point R will be the point corresponding to the second positive solution. So it will be having coordinates of 3 pi over 2, 0. We are then told that the curve has two turning points at points P and Q, and we need to show that at these points then we're satisfying the given trigonometric equation for A, B, C being integers to be found. Well, let's start by reminding ourselves of the expression for f of x, and we know that for turning points we need an expression for the derivative f dash of x. So we will be applying the product rule of differentiation here. So I will start by differentiating 2e to the 3 sine x, which is going to be 2 times 3 cos x times e to the 3 sine x, and I keep the cos x, plus we keep the first, which is 2e to the 3 sine x, and I differentiate cos x to give me minus sine x. I will then factor out the 2e to the 3 sine x, and I'm left with 3 cos squared x minus sine x. This is the expression for the derivative. And knowing that turning points satisfy that f dash of x is equal to 0, then I will simply set 3 cos squared x minus sine x to be equal to 0. I will substitute cos squared with 1 minus sine squared x minus sine x is equal to 0. I will expand this to get 3 minus 3 sine squared x minus sine x is equal to 0. And I will be collecting everything on the right hand side to make the leading term have a positive coefficient. So 0 is equal to 3 sine squared x plus sine x minus 3. In part C, we are asked to find the x-coordinate of point Q, giving our answer to 3 decimal places. So we need to start by solving the trigonometric equation here. So I'll be using the quadratic formula for sine x. So sine x is going to be minus 1 plus minus 1 squared minus 4 times 3 times negative 3 and all square root divided by 2 times 3. So I'm going to go on my calculator. I press menu, option A, it's 2 and again 2. So I will be substituting A to be 3, B to be 1, and C to be negative 3. So the first solution we get is that sine of x is equal to minus 1 plus root 37 over 6. If I press the SD button, I see that this is 0.8471 ... and I will store this on A because I will be using it later on and I want to maintain full accuracy. Alternatively, the second solution, I press the equal sign again. I get sine of x is minus 1 minus root of 37 over 6, which is equal to minus 1.18 ... Obviously, it does not fall within the minus 1 to 1 corridor. We've got no solutions here, so I say reject here, not valid. And therefore, I can proceed into solving the part here that says sine of x is equal to A. So my PV will first of all be shift sine of A. So I press menu 1, shift sine of A. Be careful, we are in radian mode here. I get a value of 1.01055 ... So this I will store it on B because it's going to be the building block for all the solutions to the trigonometric equations. So I will store it on B, and therefore we know that when we are solving a trigonometric equation involving sine, then the solutions are given by the PV, which is B plus 2 pi k, or pi minus the PV plus 2 pi k. So I press menu, it's option 9. My f of x is b plus 2 pi x, and my g of x is going to be pi minus the PV of b plus 2 pi x. So I will start at negative 2, I will end at 2, and I'm stepping every 1. So all of these solutions here are solutions to the given trigonometric equation. If I briefly go back to the given graph, we know that the point Q, for which we're trying to determine the x coordinate, is going to be the second solution because P is a maximum point. That's going to be the first positive solution to my equation. Q is the second solution. So if I go down here, the first solution is 1.01 and the second solution is 2.131. So all I have to do here is simply state that at Q, x is equal to 2.131. In question 7, we've got the curve C with equation y 16 over 9 times 3x minus k, and we need to find dy dx in its simplest form. I will start by writing y as 16 over 9 times 3x minus k to the power of negative 1. So for dy dx, we will get the power down of negative 1, so it's going to be minus 16 over 9. We deduct 1 from the power, so 3x minus k to the minus 2, and we multiply by the derivative of the bracket, which is 3, so I'll multiply this by 3. I simplify the 9 with the 3, leaving me with the 3 in the denominator. So this means I've got minus 16 over 3 times the 3x minus k to the power of 2. We are then told that the point P with x coordinate 1 lies on C, and the gradient of the curve at this point is negative 12, and we need to determine the two possible values for k. So let's start with the first fact that dy dx at this point at x is equal to 1 is equal to negative 12. So I will be substituting x is 1 in the expression we just obtained. So we've got minus 16 over 3 times 1 minus k squared is equal to minus 12. So this means that we've got minus 16 is minus 36 times 3 minus k squared. I've cross multiplied here. So if I divide both sides by minus 36, I get a 4 over 9 on the left hand side, which is equal to 3 minus k all squared. And therefore, if I take plus minus the square root of 4 over 9, it's plus minus 2 over 3, which is equal to 3 minus k. So we're looking at 2 over 3 is equal to 3 minus k, or alternatively, minus 2 over 3 is equal to 3 minus k. And therefore, we get that k is equal to 7 over 3, or k is equal to 11 over 3. Given also that k is less than 3, we need to find the equation of the normal to c at p, giving our answer in the form ax plus by plus c is 0, where a, b, and c are integers. So knowing that k is less than 3 means that k is 7 over 3, and we know that the gradient is negative 12, and therefore we can easily conclude that the gradient of the normal, I will just flip and change the sign, so the gradient of the normal is 1 over 12. I will proceed to substitute x is 1 into the expression for y to get the y coordinate of the point. So we're looking at y is 16 over 9 times 3 times 1 minus 7 over 3, which is the value of k. This gives an answer of 8 over 3. And using y minus y1 is mx minus x1. We've got y minus 8 over 3 is equal to 1 over 12 times x minus 1. I will cross multiply with 12 to get 12 times y minus 8 over 3 is equal to x minus 1. And if we expand the brackets on the left hand side, we get 12y minus 32 is equal to x minus 1. I will collect everything on the left hand side to give me 12y minus x minus 31 is equal to 0. In part D, we need to use algebraic integration to show that this integral gives me a result of lambda ln 10, where lambda is a constant to be found. So starting with the integral from 1 up to 3 of 16 over 9 times 3x minus k, the first thing to do is take out the 16 over 9, and it's the integral from 1 up to 3 of 1 over 3x minus 7 over 3, the value of k. We arrived at part C. So this will give me 16 over 9. Now the integral of 1 over 3x minus 7 over 3 will give me a logarithmic result. So it's going to be ln of the modulus of 3x minus 7 over 3. And I need to divide by the derivative of the inside, which is 3. So I divide by 3. So let me put a third here. And the limits are 1 and 3, which means we're looking at 16 over 27. And I will substitute the upper limit, which is 3. So we're looking at ln of 3 times 3 minus 7 over 3 minus ln of 3 times 1 minus 7 over 3. So I will evaluate this, which gives me 16 over 27. And we're looking at ln of 20 over 3 minus ln of 2 over 3. Now we know that the difference of the two logarithms can be written as a single logarithm. It's going to be ln of 20 over 3 divided by 2 over 3, which gives me 16 over 27 ln of 10. In question 8, we are given the graph of y is a minus the modulus of 2x minus b, where a and b are positive constants and a is greater than b, and we need to find the coordinates of the maximum point, the cut on the y-axis, as well as the cuts on the x-axis. So the first thing we need to do here is recall that the maximum, the vertex of this graph, is found when the expression within the modulus sign vanishes, when it becomes 0. So 2x minus b is equal to 0 means that x is b over 2. And if this is 0, then y is obviously a. So the vertex has coordinates b over 2, comma a. I would also like to invest a minute or so to identify each line segment with its individual equation. So the part here is a part that goes downhill. So it has equation y is a minus brackets 2x minus b, whereas the line segment on the left hand side goes uphill. So it has equation y is a plus 2x minus b. So we know that for the maximum point, the coordinates are b over 2, comma a. Now for the cut on the y-axis, I will be putting x is 0 on the equation that cuts through the y-axis, so this part here. So we are looking at y being a plus 2 times 0 minus b, which is a minus b. So we are looking at 0, comma a minus b. And for the cuts on the x-axis, we're putting y is equal to 0. So we've got a plus 2x minus b is equal to 0. And a minus brackets 2x minus b is equal to 0. So we've got 2x is b minus a, leading to x is b minus a over 2. And here we've got a minus 2x plus b is equal to 0, which leads to a plus b is 2x, and therefore a plus b over 2 is the value of x. Well, we've been asked to give coordinates, so we're looking at b minus a over 2 comma 0. That's the first point, and then a plus b over 2 comma 0, which is the second cut on the x-axis. In part B, we need to sketch the graph with the equation y is the modulus of x minus 1, which can be split. Well, the modulus sign here will do nothing if x is greater than or equal to 0, so it will behave like x minus 1 for positive x, whereas if x is negative, it will actually flip the sign, so it will give me minus x minus 1 for x being less than 0. So we are essentially looking at the union of two straight line segments, cutting the y-axis at minus 1 and the x-axis at 1 and negative 1. Your graph should be symmetrical about the y-axis, and you need to be careful so that the cuts on the x-axis do not coincide with the cuts of the previous graph. So if you draw something like this, it will be penalized. We are then told that the graphs of modulus x minus 1 and a minus modulus of 2x minus b intersect at x is minus 3 and x is 5, and we need to determine the value of a and the value of b. Obviously, the minus 3 is this point here, and the 5 is this point here. So I will be equating the minus x minus 1 with the a plus 2x minus b with x substituted with negative 3, and then x minus 1 with this equation with x being 5. So let's start by setting minus x minus 1 is a plus 2x minus b. I will set x to be negative 3, which leads to minus negative 3 minus 1 is a plus 2 times negative 3 minus b. So we've got 2 is a minus 6 minus b, and therefore 8 is a minus b. And we also have x minus 1 is equal to a minus 2x minus b. I will set x to be 5, so we are looking at 5 minus 1 is a minus 2 times 5 minus b, and therefore 4 is a minus 10 plus b, which leads to 14 is equal to a plus b. So we've got simultaneous equations in a and b. If I add them up, 8 plus 14 is 22, which is equal to 2a with the b vanishing, and we've got 11 is equal to a, and therefore 8 is 11 minus b, which means that b is equal to 3. In question 9, we've got the equation shown here, and we need to show that this leads to 3 sine 2 theta minus 4 cos 2 theta is equal to 2. So I will start by cross multiplying. We get 3 sine theta cos theta is equal to 2 plus the sec 2 theta will be written as 1 over cos of 2 theta, and I've got cos theta minus sine theta times cos theta plus sine theta. So I've crossed multiplied. So we are looking at 3. I've got sine theta cos theta, which is the structure for the double angle for sine. So it would be great if I had 2 sine theta cos theta, which is exactly the double angle formula for sine 2 theta. So I will put a half here to balance out the multiplication by 2. And this is equal to 2 plus 1 over cos 2 theta. And if I expand the cos theta minus sine theta times cos theta plus sine theta, it's just the difference of 2 squares. So it leads to cos squared theta minus sine squared theta. So we're looking at 3 over 2 sine 2 theta is equal to 2 plus 1 over cos 2 theta. And we should be able to recognize that cos squared minus sine squared is just cos of 2 theta. So let me write the cos of 2 theta here. So 3 over 2 sine of 2 theta is equal to 2 cos 2 theta plus 1. We have expanded the right hand side here. So I will cross multiply it by 2 to get 3 sine 2 theta is equal to 4 cos 2 theta plus 2. And I will move the 4 cos 2 theta on the left hand side to get 3 sine 2 theta minus 4 cos 2 theta is equal to 2 as required. In part B, we are asked to solve for x between pi and 3 pi over 2, the given trigonometric equation giving the answer to 3 significant figures. So we know we're looking for a single answer. So if we use what we have found in part A, we can see that this leads to 3 sine 2x minus 4 cos 2x is 2. And I will be using the R method to combine the sum of the sine 2x and the cos of 2x. So we've got 3 sine 2x minus 4 cos of 2x is equal to R sine of 2x minus alpha. I will expand the right hand side to get R sine 2x cos alpha minus R cos of 2x sine alpha. Now if I equate the sine 2x terms, as you can see, we get that 3 is equal to R cos alpha. And if I equate the cos 2x terms, so we can see that on the left hand side we've got 4, which is equal to R sine alpha. So 3 over R is equal to cos alpha, and 4 over R is equal to sine alpha. I can then illustrate this on a right angle triangle. We've got alpha there, so the cosine is simply adjacent over hypotenuse, where the sine is opposite over hypotenuse. So Pythagoras is giving me that R is 3 squared plus 4 squared square root, which is obviously 5, whereas tan alpha is gonna be 4 over 3. So for alpha, I'll do shift tan of 4 over 3. So if I get my calculator, shift tan of 4 over 3 gives an answer of 0.927, which I'll be storing on A because I'll be using that later. So STO and A, so it's been stored on my A key here. This means we can proceed into 5 sine of 2x minus A is equal to 2, and therefore sine of 2x minus A is equal to 2 over 5. My principal value is going to be inverse sine of 2 over 5. So I'm going to go on my calculator again. Shift sine of 2 over 5 gives an answer of 0.4115 ... which I will store on B this time. So I will store it on B. And we know that when we are solving a trigonometric equation involving sine, we've got that 2x minus A is the PV of B plus 2 pi k, or 2x minus A is pi minus the PV plus 2 pi k. So 2x is going to be B plus A plus 2 pi k. So x is a half of B plus A plus 2 pi k, and here we've got 2x is pi minus b plus a plus 2 pi k, and therefore x is going to be a half brackets pi minus b plus a plus 2 pi k. Now I can run this process on my calculator. I press menu, it's option 9. My f of x is 1 over 2, and I've got the b plus the a plus the 2 pi x, so 2 pi x. I close the brackets, and my g of x is going to be 1 over 2, and this time I've got the pi minus the b plus the a plus the 2 pi x. I close brackets. I will be running from -2 up to 2. I'm stepping every 1. So these are the solutions. Well, we know that x is between pi and 3 pi over 2. Well, pi is 3.14 and 3 pi over 2 is 4.71. So we're looking for the solution that lies between these two numbers, which is obviously 3.81, which is my final answer for part B of this question.